I'm going about my business as a measurement technician. The first thing I want to do is look at my alerts. They're the most critical. The second thing I want to do is look at my new events. As I look at my new events, the first event is a check the flow computer AGA7 flow calculation. It's important, so it's orange, and so it's going on for 1 day because it's a new event. But also we got a verified temperature measurement, which has also been going on 1 day because it's new events and it's a critical, so it's red. And so let's take a look at this temperature measurement problem. We're going to click here on the anywhere in that tile will take you here, but let's look here. Our dates again. Our current day is the 12th, and this started on the 11th. Since this problem began, so in the last day, it's caused already 5,000 MSCF in error. Our technical description here is that the flow computer temperature averaged 7 degrees higher than the verification temperature. And of course, that's a very large difference between two RTDs trying to measure the same temperature. The shift occurred at 11 a.m. To view the event, select the temperature and temperature percent difference graphs from the chart analysis dropdown. We'll do that in a minute. Yesterday, the meter flowed 437,000 MSCF a day at basically 36 feet per second. So you know there that the meter was flowing at a good clip while this event took place. And so let's the recommendation is then begin by verifying the flow computer and verification temperature sensors, and to calibrate and or replace as needed. So we see here in our graph, this is the temperature, measurement temperature. We see the flow computer is in green and the verification is in purple. It looks similar to the last graph we looked at. I see that my green goes off the charts over here. Remember, we said it went 7 degrees higher was what the message said. And so let's just pull our date range in, and we'll be able to see that. There we go. So now I got the date range pulled over very nicely. I can see the problem. I can see here it looks like at the worst of it, my flow computer temperature is measuring 102, while the verification temperature is only measuring 87 degrees. In fact, if you look at this pattern right here, up and then down, and this pattern starts to pull away at around 10 in the morning, and it hits its peak up here at around, what is that, 15? So that'd be, 17, so that'd be about 5 o'clock, and then here's 6 o'clock, and then it starts to go down. We can figure out, in fact, by using our other graph, we can figure out which one of the two temperature measurements is in error. So I'm going to come down to my second graph. My second graph, the first graph will always have the graphs that are most relevant to the problem. The second graph is the kitchen sink. It has every graph in it, so you can relate your problem to whatever else you want to look at. In this case, I want to use this graph to look at the speed of sound percent difference. Right here, the USM to AGA10 SOS percent difference. The reason I want to pick that is because when the speed of sound is calculated using the equation of the state and the pressure and temperature, it uses the flow computer temperature to calculate the speed of sound. And so here I'm getting a difference between the calculated speed of sound and the meter measured speed of sound, and it's inversely related to my temperature difference. And so that tells me right away that it's the custody, it's the flow computer temperature measurement that is in error. And so that would drive me to go take action, to go probably a sharp tech looking at this screen would right away intuitively know that RTD is not installed into the thermal well, and they need to take a trip out there to the meter station and get that RTD back into the thermal well.